Section 3.3 Day 1 is all about looking at data and trying to find the line of best fit. So the warm-up, we can see that we have a scatter plot showing car weight for the independent variable and miles per gallon for the dependent variable. And if you looked at this, it looks like there's a trend here that as the weight of the car increases, the miles per gallon decreases. So the question is, can you draw a line of best fit? So drawing the line of best fit, it would make sense that the slope would be negative. Your line might look something like this. Can you explain why you might draw your line this way? And there's a question. Does a line of best fit always have to start at 0? Explain why or why not. So line of best fit you talk about in science quite often, and now we'll talk about it in math as well. A line of best fit has pretty much two restrictions you should follow. Number one is that the line should have the same slope as the direction of your data. So the slope follows the slope of the data. So follows slope of the data. Step 2, and again you talk about this in science, your line of best fit should have about the same amount of points above the line as there are below the line. So same number of points above and below your line of best fit. Now one common thing that people like to do, two common things actually, is they'll draw a line that looks like this. They'll want to start it at 0 and they might not follow the slope. Now this would not be a good line of best fit because it doesn't follow the data, and again a lot of people want to make it start at 0, but your line of best fit doesn't necessarily have to start at 0. Another example, sometimes at sporting events, people in the audience stand up quickly in succession with their arms raised and sit down again. The continuous rolling motion is called the wave. You and your class will investigate how long it takes different size groups to do the wave. So in class we actually do this investigation, but right now we have this data right here, so take a few minutes and see if you can graph this data, and then we'll draw a line of best fit. So if we look at the data, it starts at 2 people up to 22. So if you scale the x-axis by 2, the data should fit. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. And if you look at the time, it only goes up to 11, so you should be able to scale by 1. So I'll just write every other 2, 4, 6, 8, 10. And then again, put your coordinates. 2, 2.1, 5, 4.4, 6, 5.2, whoops, I put that in the wrong spot, 4, 5, 4.4, 6, 5.2, 8, 5.8, that's more like up here, 9, 4.7, 10, 6.7, 15, 7.5, 16, 10.4, 22, 11, okay, so there's our data. We can draw a line of best fit, again using what we talked about, follows the slope of the data, about the same amount of points above and below the line. And then, this should be review, you're expected to know how to come up with the equation. Since this is linear, we know we can use the form y equals mx plus b, where you have your slope next to your x and your y-intercept, your starting value. Sometimes you might see it in this form, y equals a plus bx, which is the same thing. They just put the starting value first, and notice the slope is still next to the x. So according to our line of best fit, it looks like the starting value is 1.5. And if we count our slope, we're just going to pick 2 points on the line of best fit and count rise over run. So I'm going to try to find 2 points that might work. None of these are looking great. So maybe I'll pick this point right here and this point right here. Again, they're not the best points to pick, but it looks like we're going up 2. Yep, this looks like about 2. And we're going over, remember how it scales, so we're going by 2's here. So we're going up 2 over 4. So our slope would be 1/2, or 0.5. Oops, I wrote this in the wrong order. So we have y equals, I should have erased all that. Y equals 1.5 as our starting value plus our positive slope, and it was 0.5x. So here's the equation of the line. All right, let's use that to answer some questions about our data. So plot the points. Again, here's our equation. We started at 1.5. So y equals 1.5x plus our slope. Oh, I wrote it wrong again. Y equals 1.5 as our starting value plus 0.5x. So this says, what is the slope of your line? So again, our slope was 1/2, 0.5. And what is this real world meaning? So if we look at the graph, time is the y value, number of people is the x. So this would be time, and this would be number of people. So the real world meaning of our graph, it looks like for every 1 second, 2 more people will do the wave. 1 second. 2 more people. What are the x and y intercepts of your line, and what are their real world meanings? Okay, let's go back to the graph. So here's our x-intercept. Maybe we'll use a different color, black or green. Green. Here's our x-intercept. Our y-intercept, that's actually our y-intercept. And our x-intercept is over here. It's going to be negative something. So if we estimated maybe -4. So the y-intercept, what that stands for is when there's 0 people, how long does it take to do the wave? And our x-intercept over here means number of people at time 0. So for this situation, since we don't start at 0, 0, our x and y-intercept might not have a whole lot of meaning. But again, our y-intercept is the starting value, so at 0 seconds, how many people are doing the wave? What is a reasonable domain for the equation? And we talked about domain yesterday. Domain, we're looking at the x values. And since we're looking at number of people, a reasonable domain would be whole numbers, of course, and they would be positive. So however many people could fit in wherever the stadium is or whoever is, or wherever the wave is taking place. So x values for this one would be positive, whole numbers. Because it's people. And it might go from 0 to however many people can fit, people that are in the place that you're doing the wave in. So 0 to total number of people doing the wave. Can you use your line of best fit to predict how long it would take to complete the wave if everyone in the school participated, if everyone in the large stadium participated? Explain why or why not. So again, here was our equation, 1.5 plus 0.5x. And you could use it to predict if the trend continued. So if it stayed the same pattern, linear, we could use this. But here's where we would put it, the number of people. And then we would get our answer in time right here. So again, you could use it, and it would only be accurate if it followed the same trend. Okay, our next question. So we did it by hand. We looked at graphing and finding the slope and the y-intercept. Let's use our calculator to also find the line of best fit. So while I pop up the calculator here, we'll talk about independent and dependent variable. The following data is the temperature and the number of visitors in thousands to a water park. So we're going to enter this data into a list. You could also do it by hand and come up with the line of best fit. So we're going to talk about independent and dependent variable. So think about which variable does not depend on the other one. So here the independent variable would be temperature, and the dependent would be the number of visitors. And the reason is the number of visitors would depend on the temperature. Okay, so in a graph, our independent variable will be our x, and our dependent will be the y. So I'm going to wait for this to load, and I'll show you how you can put this in the calculator, and then we're going to come up with the line of best fit. Okay. So again, remember this is our x, temperatures are x, oops, x, and this will be our y. Okay, let's put this in. Grab a calculator here. Okay, so here's my calculator. And I'm just going to follow the instructions on our sheet. So we are going to add a list and spreadsheet. We're going to do temperature. So I'm going to label one column temp. And I'll call the other one number of visitors. And we're just going to put in the numbers. So temp 62, 67, 69, 70, 72, 77, 79, 80. So I'm just taking these numbers right from the chart. 83, 85, 88, 94, 96, 98. Oops. Okay, and then number of visitors will go over here. So this is in thousands. So 58.9, 56.1, 57.3, 57.7, 51.5, 48.4, 45.4, 45.8, 42.3, 44.3, 37.1, 36.9, 40.9, 36.8. Okay, so once you have your numbers in the list, let us open a new document. So Control Doc, and we're going to graph this. So we're going to go to Data and Statistics, and we're going to click to add the variable. The dependent variable was temperature, so I'm going to choose that. Independent was visitors, and we have our scatter plot. So the next question is, does our data appear to be linear? And it does look like we can draw a line of best fit. So to do the line of best fit, we're going to hit Menu, and we're going to analyze our graph, and we're going to look at regression. So line of best fit is a line of regression, and it's linear. And again, there's two that you can pick, and they're both the same, but one starts with a slope and one starts with a y-intercept. So you can do either. I'll do the second one where it has our starting value first, negative 7.109, plus our slope. So there's the equation that we'll write down. So I'm going to go back to my document. Okay. So the equation for the line of best fit. Again, looking at our calculator, the y-intercept was negative. You can see it's not 0, it's negative. So negative 7.10939, and then plus our slope was 0.677617, x. Remember, x stands for temperature and y stands for the number of visitors. Use the regression equation, so your line of best fit, to calculate, and I should put y equals the number of visitors to the pool when the temperature is 90. So for this one, we're going to plug in a 90 here for x and calculate. And for the second question, it says use the regression equation to calculate the temp when there are 50,000 visitors, and use 50 instead of 50,000. So for this one, we'll plug in a 50 and solve. Okay, so the second one, solve for x, use algebra. The first one, plug in a 90, and you can just plug that right into your calculator. If you want to check, for this one, I get y equals about 53.87 thousand people. And for this one right here, if we solve for x, temperature was about 84.3 degrees. Okay, so there's using the calculator to find the line of best fit, and then using that line of best fit to calculate two things, number of visitors and also temperature. So there's one more example you can try in your calculator following the same steps, and then you'll answer the question. So we're looking at Duncan in his water skiing sales shop. Again, follow the instructions on the calculator to find the line of best fit, answer the questions. And your assignment then is similar to this, and it's the next worksheet. I think it's called 3.3 Day 1 worksheet.